Hello, welcome to the Center for Innovation's online salon series. I'm Margie O'Driscoll, and on behalf of the Center for Innovation's Board of Directors, I'd like to welcome you here today. This is a new introduction for us as we recently rebranded. We are transforming ourselves away from the very hard to remember acronym of CIDCI to a more succinct name that better describes our mission. We plan to keep the CIDCI Foundation as our legal entity, but henceforth we hope you'll find it easier to remember who we are with a name that better responds to our mission and goals. So, welcome to the Center for Innovation. We have also launched a new website, thecenterforinnovation.org, and look forward to your comments. We will continue to offer the same great programs, including the Research to Practice initiative, which invites students from around the world to submit a solution to a wicked problem in the AEC industry. We will be awarding at least $5,000 in prize money to individuals or teams. The deadline has been extended to August 26 due to high interest, so please be sure to share this opportunity with any students in your network. Registration is also open for the Innovation Lab. Participants in the Innovation Lab will learn tools from design and systems thinking and apply them immediately to their own projects. They will leave with an appreciation of how to better understand stakeholders, how to frame opportunities within messy problem spaces, and how to conduct rapid experiments to test new ideas and products. The online asynchronous course is a 6-module class that opens a week from Friday. This course will be led by Vivek Rao from the UC Berkeley Haas School of Business. Spaces are filling up quickly, so please be sure to register soon. We would also like to thank our sponsors who support all of our work, including today's webinar. Today, we are so delighted to feature a conversation with John Gambatese. He's a professor at the School of Civil and Construction Engineering at Oregon State University. His research is in the broad area of construction engineering and management, and more specifically related to safety, prevention through design, work zone safety, risk and reward, innovation, and sustainable and lean practices. Today, John will give us a wide-ranging overview of prevention through design, or PtD. This PtD aims to improve safety and health through the elimination of hazards before they exist on the job site. John will discuss the foundational support of this movement, examples of safe designs, and guidance for practical application. John, we're so happy to have you here and able to join us today.
Good morning, and thank you very much, Margie. Appreciate the opportunity to come and speak.
Great. Do you want to get started?
For sure. I'm all set. So,
okay, great.
All right, and good morning to everybody who's out there in Zoom world. So happy to see you on the list, and happy to be here this morning, as I said, and to share with you what I know about prevention through design. As you can see there, as Margie said, we'll be focusing on the topic of PtD, prevention through design, and how we can make a safer construction industry. And this goes back to a number of years ago when I was in graduate school. I actually went to UC Berkeley for a couple degrees and then the University of Washington. And I was introduced to the topic in the University of Washington as I focused on it in my PhD research, and identified it as a topic of interest that I think was supposed to be something that we all kind of assume happened, but maybe didn't happen in the real world of engineering and construction. I myself am a former structural engineer in the San Francisco Bay Area, and did a lot of design. And now I focus obviously on academia, but also on how do we design for construction. And I can recall a situation many years ago where it was right after the Loma Prieta earthquake, which you probably remember. And I remember designing something in the office that was going to be built right after the earthquake during the period of aftershocks. And I recall I was a young engineer, not knowing much, but at that time, I asked my supervisor, should we design something into our system that we were designing as part of this building? Should we change the design in a certain way to make it safer for the contractor during this period of aftershocks? And I still remember that conversation, and the response from my supervisor at that time was, no, that's for the contractor to worry about. And I think since that day, many years ago, we've changed a little bit in our culture. We've innovated, we've had some transformations along the way where we think that safety is much broader than simply just putting it on the contractor's shoulders. And that's what I'm going to talk about here today. How do we do that as an industry, whether you're on the design side, whether you're on the owner side, or some other part of the project. So I'm going to dive right in. If you have any questions, please let me know. I'd be happy to answer them. So I'm going to start out with a real quick question. We're talking about innovation here, and innovation is change and changing ideas, perhaps. And the first question is very simple. So it's 8 o'clock in the morning Pacific time, and maybe you're still getting your coffee, but real simple question. So what is a roof? And if you think about it for a second, you can mull over it and maybe put something in the chat. Think broadly here. What is a roof? You're sitting in a building, I assume, and there's a roof over your head. So what do you think about when you think about what a roof is? I'll give you a hint. There's an easy one, right? There's a easy one that is, it's a protective covering, right? We're going to protect ourselves from the weather. That's very easy. From the snow, from the rain, whatever it is, we want that protection. For those of you that are on the architecture side, maybe you're also thinking, well, it's an architectural feature. And that's certainly true. Many of our buildings that we design the roof specifically to provide an impression to go along with the aesthetics of our design. And we want it to be an architectural feature. Importantly, and the focus of what we're thinking about today is that it is a workspace as well. And that workspace is important for those people who work on that roof, whether you're going to repair that piece of equipment, or whether you're going to build that roof, or you're going to put on the roofing, you're going to clean it, whatever you're going to do, that's a workspace. And we have to think about that as well. So rethinking what a roof is, it's not just a protective covering or an architectural feature, but it's a workspace. And I could perhaps list quite a few others on that list there of what a roof is, but primarily what we're going to dive into is that workspace part of it. So start off a little bit more with some background information and just talk about design. That's what the focus of this presentation is primarily. It's about design and how we see design and its impact on our lives. So first of all, we recognize that design is a powerful ability where we can build wonderful things, design and build wonderful things, whether it's the Empire State Building, the Golden Gate Bridge, or Hoover Dam there. Wonderful things that we've built throughout our country and our society that benefit us in many different ways. We have the power to do many things through design. Along with that, we have to realize that good design demands attention. And as you can see there in the photographs, the designs perhaps are not the best designs, right? For the person who's the homeowner, that driveway is a little bit steep. For those stairs, it's very hard to see the stairs, so they're fairly dangerous. Or the air intake is right next to the exhaust there, and so you wonder who designed that. So a little quote there from Francis Bacon, but predominantly we need to recognize that if we don't think about our design, something could go wrong. So we need to pay attention. If we don't pay attention, we will create designs that don't work or perhaps are unsafe for us. Next, we also have to realize that design influences project success. How we design our building or a bridge or a road, whatever it might be, impacts the success in terms of cost, schedule, quality, performance of that design, safety, and so forth. And the ability to influence that project success, as you can see there in the chart, is very high early in the project during conceptual design, detailed design, and so forth. Later on, we have less ability to impact project success. Also, the cost of making changes is greater later in design. If we are going to change the design to improve it, the cost is going to be greater if we are in construction or later on after construction. In that vein, design influences safety as well. As you can see here in the quote, the ability to influence safety is greatest early in the project schedule during planning and design. And as you can see on the photos on the right, this was taken from the top level of a parking garage, where on one side of the wall there, the exterior wall, is the street down below. And on the other side is perhaps a place where someone could stand on it, a little child or anybody could stand on that and be exposed to a hazard down below. So that design, that falling hazard is created due to that design. So an example of how design influences safety. That brings us to this concept of prevention through design. And this topic, prevention through design, as it's labeled, has been around for a number of years. And a definition that NIOSH, the National Institute for Occupational Safety and Health, has put together to recognize what prevention through design is. NIOSH focuses on all industries. So not only design and construction, but agriculture, mining, manufacturing, and so forth. So this is a very general definition, but it's basically the effort to design out hazards to workers before they exist. So we're going to look at the facilities, the methods, the operations, processes, and equipment. So before they are there on the work site or in the workspace, we're going to design them out. I call it safety constructability for the construction industry. You can also read about it in terms of safety and design, design for safety, life cycle safety. Those are similar terms that we've heard over the years. So prevention through design. It's not a new concept. In fact, it's been around for many years. Here's an example. Perhaps you visited this site in Wales. It's described on the World Heritage website. It's listed as one of the World Heritage sites, and it's the Pont Cysylltu Aqueduct and Canal, if I said that correctly, in Wales. And you can see a couple pictures of it there and some original drawings. What did they do on this project? Well, it describes it in the documentation that the engineers gave unusual attention to the safety of the workforce. They designed in wider piers so that workers could get around the work site a little bit easier, so made them a little bit wider. And they also designed the upper sections to be hollow so that they were a little bit lighter. They could be handled a little bit easier. So we've had this concept for many years, and we understand what it is. It's being implemented now, obviously, but maybe not to the extent that we would like. And we are trying to develop resources and things to help the industry implement this concept. Importantly, we have to recognize also what PtD is not. And I give presentations, and people always talk about means and methods and architects and engineers participating in safety during design and responsibility for safety. Well, what PtD is not is those three things. So it's not a suggestion that architects and engineers or designers should participate in safety during design. They're not there to provide that guidance to the contractor or the workers. They're not prescribing the means and methods of construction. That's up to the contractor, rightfully so. They have the contract for that. That's part of the contract. And they have the knowledge, right? When I was an engineer, I didn't do that. When I was a student a long time ago, I wasn't taught anything about safety on construction sites. So it's also not something that we suggest that the architect and engineer bear a responsibility for worker safety. It's simply, as I design something, think about how that design impacts the people who are building that design, maintaining that design, using that design, all of those, and maybe change the design in a certain way so that it's as safe as possible for those three parties. So it's basically making safety pre-thought, not an afterthought, as we see in this figure here. So moving it back upstream to design, to the conceptual design, detailed design. It's easier to do it when it's at that part of the project, and it costs less. Now, that's not to say that there is an important part of safety during construction as well. There certainly is, that we have very much of an influence on the safety as part of the contractual requirements and as part of the work operations and so forth. So there's a big impact there, but we also have an influence of the design on safety too that we have to address, and also we can promote, and therefore we have better safety during construction, during use, and during maintenance of our facility. There are a couple important questions that may come up as we go through this, and I wanted to address those. Or those questions are, what is being designed, and then also whose safety is being considered. And as you can see in the table there on the left-hand side is a list of things that we perhaps design. We perhaps design the permanent structure or the permanent equipment, or maybe we design the temporary structures or the process of constructing. We design that process or the equipment that we use during construction. And on the other columns, we focus on whose safety are we targeting? Is it the safety of the constructors, the safety of the end users after the facility is built, or the safety of the maintainers, or all three? I wanted to address this real quickly to kind of focus in on the discussion and where we're struggling perhaps a little bit and where we need to put more attention. So first of all, we need to recognize that the end users, the operators and the maintainers, they don't really get involved with the temporary equipment, the temporary structures, and the construction work process. So that's not applicable. A couple other cells there. So the end user and the operator, they are very much affected by the permanent works, the structure, the facility, the equipment. And we actually do a good job at that. We have building codes, we have lots of standards and regulations. And so we do a very good job. So that's the safety of the person who's in the building after it's built, or driving across the bridge, or working in that industrial plant. We do a good job there. We also do a good job, fairly good job. We could do better. We have OSHA regulations, and those OSHA regulations focus on the construction phase, the work process, the equipment that's used, the temporary structures. So there's quite a bit of focus there in our academic and our industry practice world. What we don't do a good job at, and where most of the focus of the research is where we design perhaps the permanent structure or the equipment for the safety of the constructor or the safety of the maintainer. That's where most of the research going on today is focusing on. How do I design a column or the rebar or the layout of my facility to make it safer for those who build that facility? As part of its life cycle, it's going to impact people in different ways, whether it's in partially built or in its final form, or when they have to maintain that. So that's where I get involved in much of my research, and where, if you read some of the journal articles, that's where people are targeting. Let's dig a little bit deeper into that. And I want to show you some examples here. Maybe you've seen something like this. This is an example that is fairly easy to recognize, and it's simply bring the work to the worker, not the worker to the work. As you can see there, the worker up in the man lift trying to replace that lamp. And that creates a hazard for that worker. There's passing traffic, also being up in the air at elevation. Why not design that lamp post to be so that it can rotate down, so a worker can simply change that bulb, that lamp, right on the ground? That's a very good example, and it can be applied to lamp posts. It can be applied to any type of work or design within our facility. Other examples, there are quite a few. I show some pictures of some here, color coding the piping in the upper left there so that we can readily see what's in the pipe. So if I am doing some work during commissioning, some rework, or maybe maintaining that facility, I can easily tell what element or liquid or gas is in the different pipes. The center one there is something I call mistake proofing, or poka-yoke, and that is designing something so it can only be used in the right way. We can only put that plug in one way. In the bottom picture there, the red concrete, so that later on, if we are doing some work in that area, we uncover the red concrete and we know that there's some type of a hazard, utility hazard in there. So we stop and we don't continue unless we know that we have turned off the utilities or protected our workers. The very right one there is a very useful resource, and it's about steel design and how I can design that steel to cover up that dangerous corner there, that hazardous corner on that gusset plate. Either cut it off or cover it up with that angle. So quite a few examples that are available, and checklists and things that are available online. If you'd like, I can point you in the right direction to find those. What is this founded on? The foundational support for this comes from something called the hierarchy of controls. And if you have a background in safety engineering or safety management or safety science, you've probably learned about the hierarchy of controls. It's basically saying, okay, if we have a number of controls, which one's better than the other? Is there a difference between types of controls? At the very bottom, we can put on personal protective equipment. We can put on a hard hat and steel-toed boots and a safety vest. But maybe better than that is we change the way people work. That's an administrative control. So we change the process. Or maybe we put up a sign to warn people so that they don't walk in a certain place, or maybe they don't step on that top step of the ladder, right? That's an administrative control. Above that, a little bit better, is what we would call an engineering control. We're going to isolate people from the hazard. So that's that guardrail around the skylight, or that grating over the skylight. That would be an engineering control. The hazards are still there, but we are protecting people from that hazard. Above that is substitution. We're going to replace the hazard, make it a little bit less hazardous. And at the top of the hierarchy is elimination. We're going to remove that hazard altogether. So that would be that building on the right-hand side there without any skylights at all. And maybe that's okay for your building, although maybe you want skylights in your building. And so what do? If you can't eliminate the hazard, you use a lower level control. That lower level control might work, but it's a little bit less effective. Maybe the hazard still exists. Maybe it doesn't really protect the workers as well as you would want if it's PPE versus perhaps an engineering control. Importantly as well, we don't only have to use one control. We can use multiple controls. The goal, though, for prevention through design is we'd like to go higher on the hierarchy of controls as much as possible. We want to eliminate that hazard, or at least substitute. So those two top levels are what we're focusing on. How do we do that? We do it in the design of that facility. There is some industry support, and perhaps some of you have seen this if you're involved in the LEED accrediting system. USGBC has a prevention through design LEED pilot credit that's available. It has two different parts. There's a safety design review and a safety constructability review. And a safety design review is focused on primarily the safety of the end user and the maintainer after the facility is built. The safety constructability review focuses on the safety of the constructor during the life cycle of that facility as it is being built. How can that design affect the safety of the people who are building it? So I encourage you to take a look at that and perhaps include it in your projects as well if you're going for a LEED rating. There's more motivation as well. We try to, in research, try to identify what the potential impact of the design is on safety or on injuries and fatalities. And that's a little bit of a hard thing to do. We talk about what do we do during design and try to relate it to the safety of the worker and the injuries that occur. And there are many things that go on in between. We have many different safety practices. So it's a little bit hard to filter it out, but we give it a try. You can see some research that's gone on here where 22%, 42, 47, or 60% of the incidents, injury and fatality incidents that have occurred could have perhaps been prevented if some different decision occurred during design. We don't know exactly what that is, maybe 20%, maybe 60%, but in that range, perhaps. Still, 22% is a good portion when we're talking about injuries and fatalities. If we were to eliminate that many injuries and fatalities, that would be a very significant impact to our industry and a very positive impact. So we know that there is an influence by the design on safety during construction. That HVAC ductwork there on the right, just to mention that, so an oval piece of ductwork rather than round. So when it's sitting on the site there, as you can see, it doesn't roll over, and there's no hazard that workers are exposed to from that potentially rolling over on them. A little bit more motivation, and the Center for Innovation is a good connection here. So innovation is something that we have actually seen as we focus on prevention through design, the impact of PtD efforts on design. So if we try to push up the hierarchy of controls, as you can see there in the colored bands, from personal protective equipment to elimination, it takes more effort during design. A little bit more thought goes into the design, but by doing that, we have found that there's quite a bit of creative potential, and the designs that come out afterwards are innovative. And if you think about it, if I've got a challenge, I'm going to put some time and effort into it. I'm going to think of how to do it differently, and I'm going to get an innovative design. So aiming for prevention through design has led to these new ways that we design our buildings and our bridges and so forth. Okay, so that's all about PtD. Let's look about what's been happening in practice and what we've learned about practice. And I want to focus on 4 different areas: inhibitors, enablers, resources and tools, and measures of effectiveness. So this is now as you move forward in your own world and you try to implement PtD, what are the things that you're going to be faced with? What should you use to implement it? How are you going to measure whether you're doing a good job or not? So first one is inhibitors. We often talk about what's hard about PtD, and that's where these inhibitors come up. And I purposely use the word inhibitor rather than barriers, because barriers identifies, in my mind, something that prevents PtD from happening. And we know that there are many organizations and projects that are implementing PtD. So I would call them inhibitors that maybe slow it down, but not prevent it. And so at the top of the list, designer education and training. Here in academia, we struggle with that, is educating our engineers who are going to do the design about safety. So we are working on that. Training them on the site. What's the impact of their design as they walk around a site, get them that construction experience so they learn about the hazards so that they can address those in their design. Maybe unclear authority and responsibility, a questioning, should I do this as part of my design contract? Competing priorities, right? We've got cost that I have to worry about in my design, schedule, quality of the design, meeting all the owner requirements, the client requirements, and now safety. I've got aesthetics. How does safety fit within that priority list? Contractual separation. Am I on a design build contract, IPD, or is it design bid build, general contracting? How does that work? That's an inhibitor. There is some cost and time required, and there's a fear of liability, which is something that we need to address in the industry as well. If I start designing for safety, not prescribing means and methods or taking action during construction, but if I simply change the height of something in my design or the layout or the detailing of my rebar, how does that affect my liability? Do I have insurance, E&O insurance that'll cover that? And then it's difficult. Perhaps you can see the figure on the bottom right. That's a cross section of a microchip manufacturing facility. how do I know what the safety hazards are if I'm just looking at that on my computer screen? It's perhaps difficult. There was some research here that was done, reported back in 2015, where they did a survey of people out in practice and asked them, what are the impediments to prevention through design implementation? And you can see the list there, starting at no immediate financial incentive, lack of regulatory requirements, and so forth down the list. And they came up with a ranking based on this survey. What do you think is number one on the list? Which one would be the biggest inhibitor or impediment to prevention through design in the industry? I see Margie put a number 8. All right, lack of knowledge and training. That's a big one for sure. And that's why we have the webinar, right? I'll give you the answer here. I'll spill the beans, make it easy for you. So 1, 2, 3, 4, 5, and 6. And there was a tie there, and then number 8. So the number 1 was financial incentive, right? What's in it for me? Why should I do this? I don't have to do it right now. I'm not required to per contract or the building code or OSHA or anything like that. So why should I? Secondly, lack of regulatory requirement, right? And then thirdly, lack of recognizable duty. The relative index there has to do with the relative difference between one impediment and the other. They're fairly closely spaced, so they're all very important. But number 1 is the financial incentive for A&Es. Let's focus on what helps us out rather than inhibits us. And what helps us out in PtD are, if I'm committed, right? I've got an owner, I've got a designer, and they're committed to safety. They've got a good safety culture. And if the owner or the client tells me as an architect or engineering firm that on this project, I would like you to consider safety and design, I will respond and I will provide that service to my client. I will need to have the experience and the training or the education. So that's a benefit, an enabler. 2 types, one in the area simply of construction. How do they do the construction? What are the operations, knowing the construction process? And secondly, the safety involved in that process. If I understand what the hazards are, then I can design them out. If I use an integrated project delivery method, design, build, CM, IPD method, that helps, we found. And then also if I use some visualization tools, some type of 4D CAD system, VR, augmented reality, virtual reality, so forth. There are resources and tools that are available that have been created and are publicly available. I can point you to those if you're interested. There are some websites. There's one on the right-hand side there that I show. That the one on the right, construction slide rule, allows a designer to go in and put in information about their building in this case, and then it'll give them a relative risk rating in terms of how their design impacts safety of people who are building that design. There are quite a few checklists that are available. There's risk assessment pro forma, these documents that can be used to assess risk, BIM tools, databases, risk design risk calculators. Risk mapping is a process that can be used where you look at a map or a plan of the facility and identify the risks. So those are available, and I encourage you to use those as you move forward with PtD. Lastly here, when we do implement prevention through design, how do we know we're doing it well? And that's where these measures of effectiveness come in. And these haven't been developed so much, and we're starting to try to figure out what should we focus on. Perhaps we focus on the percentage of procedures designed that take safety into account, or the number of safety needs detected in design. As perhaps some of you, if you're on the design side, when you're going through the design process, you have a design log with comments from people. You do peer reviews, value engineering, constructability reviews, and you create this log. Well, how many of those focus on safety during design, during construction, during use or maintenance? And then how many of those are you actually changing the design to eliminate the hazard, rather than just saying, oh, we'll let the contractor figure that out, right? That's not our world. That's something for the contractor to worry about. So we can use that number or percentage as a part of measuring the effectiveness of our program. There are quite a few others. There's a reference down there at the bottom that you can look at to identify what might you use for evaluating the effectiveness of your PtD process. Let's give it a try. And here are a couple pictures here. So let's put it into practice, what we've learned, and maybe see if we can do it. So the question here is, what design-related safety hazards do you see in these images? Left-hand side, you can see it's a building. It's being built. You can see the metal deck there, the rebar, the columns going up, and it's ready perhaps for the concrete to be placed. On the right-hand side there, you can see the utilities being placed below. This is going to be a mat slab. So they're roughing in all the utility lines for that. So as you look at those images, can you see any design-related hazards? And I've shown these to people before, and they definitely see hazards. And for example, on the left-hand side, maybe that rebar, you can trip on that rebar. That spacing and size of that rebar is a design choice. Maybe rather than looks like a 10 or 12-inch spacing there, maybe we use a welded wire fabric or something where the spacing is less. And we could use smaller size rebar so that it's easier to walk on. So that would be a design-related hazard on the left image there. On the right side, usually when I ask people design-related hazards, they say, oh, look at that shovel right there. That's a tripping hazard. And then I say, well, okay, let's focus on design-related hazards, not construction-related. And then they scratch their head a little bit. And usually they come up with the layout of that piping. Does it have to be laid out that way? Can we organize it a little bit better so that during construction, it's not such a plate of spaghetti, right? And easier to walk through. So there are some design-related hazards there. However, I should say that this really isn't what we're talking about. We're talking about the design phase. And when we are in the design phase, what are we looking at? We're not looking at this. We are looking at something like this. And the process and the request to answer this question, what design-related safety hazards do you see, is perhaps a little bit harder. And obviously this drawing is very small and you might not be able to read the writing there or what it is, but it's a little bit harder to envision what the hazards will be during construction or during maintenance, predominantly during construction. And so we have a tough task in front of us. How do we go from this to identifying construction-related hazards? And I won't get into the design of this and what the hazards might be. It's a little bit too small to see, but think about that and how you might do that. So what do we use to identify the hazards or prompt us on what those hazards are? So there's two things that I'd like to show that help prompt us. One of them is this use of energy mnemonics. And there's this energy wheel here, and perhaps you've seen that. Perhaps you've taken a class in physics many years ago and learned about energy and what it is, the ability to do work. And there are different types of energy, whether it's gravity, temperature, chemical, electrical, mechanical, motion. And so what we found is that if we have an energy mindset, we can look at a design and think about where the energy exists. And when we identify where the energy exists, we can then identify the hazards. We've done some research that relates the amount of energy to the severity of an incident or an injury. And there is a correlation there. So more energy, more severity of the incident. So follow the energy is one way that you can prompt yourself to identify those hazards. Another way, perhaps if you forgot everything from your physics class, is you can focus on guide words. And here are some guide words that I've developed in different categories: dimensions, actions, interactions, positions, surroundings, design, human interface, and system performance. So as you look at a design, you can think about size or shape or access. Access is a very big one. How am I actually going to access that location to install that piece of pipe or that piece of equipment? What do the perimeters look like? Are there openings? Can I make the openings smaller? Can I put those openings somewhere else so they're not so dangerous? So these guide words are designed to help an architect and engineer think about their design in certain ways and focus their thinking on what the hazards might be during design or in their design as well. Okay, we can also use another tool that is very helpful. Participated in a research study where we looked at the concept of visual literacy and how visual literacy can be used to improve our ability to see things, in this case, to see hazards. There's a lot of work that's going on these days into improving visual literacy, where I look at an environment. That environment can be my physical environment around me, or it could be any type of data. Could be a photo, could be a chart, could be a table of information. How do I look at that information or that environment and improve my understanding of it? As I apply it to what we're talking about, we perhaps look at our design and we ask ourselves, what do you see? And then we go to, what does it mean? And then what do you do about it? And that's this visual literacy concept. And so if you've gone through the training on visual literacy, you learn about concepts of design and how to look at a design based on color and shape and orientation and things, how to physically look at a picture and gather all the information that you can from what's being presented. And so perhaps what you can do is in your organizations is go through some visual literacy training, and that will then help your people understand what the hazards are as they go through their projects, through their designs. Continuing on here with a little bit more, we have different processes that we might implement, and those processes focus on different phases of a project, whether it's the conceptual phase, design, 30% design, 60% design, or 90%. I think those are very familiar to people. And here's some suggestions on who to involve and what to focus on. So the owner, the AE, the GC or CM, what do you do during conceptual phase and so forth? I recommend predominantly during the design, if you can, if your contractual method would allow, to incorporate those lead subcontractors, the mechanical sub, the electrical sub. Those people really know what the hazards are. They're exposed to those hazards. So I recommend that you incorporate them as much as possible. I had the opportunity to go to the UK and study what's happening over there. They're very much ahead of us in terms of prevention through design. They actually have some requirements, some regulations that say anyone doing design has to address the risk to anybody downstream of their design. We don't have that in the United States in terms of construction safety. So this is focused on construction safety. And the question that we asked was, what were the changes that occurred as a result of implementing prevention through design? And a small number of responses, but it still gives an indication of what we would expect here in the United States also. So what's the impact on design cost or construction cost, or design duration or construction duration? You can see the responses. These are opinions, obviously, and whether the cost would decrease, not change, or increase. I'll focus on a couple that I think are of interest. So construction cost and construction duration. So we would see a little bit of an increase there. That's according to some percentage of the people that we surveyed. Many said no change, some said would decrease. What we'd like to see is the design duration and the construction quality. There's no change, or maybe some increase predominantly, but no change in that. Also, importantly, we'd like to see productivity increase, which we found out, as well as construction worker safety and end user health and safety. So there are some benefits, but also perhaps some cautions there. Okay, with that, let's talk about PtD in the future. What do I see in terms of what's going to happen in the future? How do we move forward? What are the things that are being worked on? And one of the things that we hear about a lot today is artificial intelligence. We hear that AI term quite a bit. And so there are efforts going on to utilize AI during design. So as I perform my design, do we have some type of a technology that can evaluate my design as I go through and develop it? And that evaluation process will provide information about the safety hazards that are created during the design. And that's got some legs to it where it's in the process. Part of that process is figuring out, okay, if I design a concrete column, what are the activities that are involved in building that column? And then for each of those activities, what is the risk associated with each of those activities? So I worked through that problem with a student a number of years ago and created a process where we could, as you see in the graphic there, we could start with the BIM model. From the BIM model, create a schedule that shows when the design elements are going to be constructed, and then attach a risk rating to those design elements so that we could create a risk graph. So that's the one on the middle on the right-hand side there, looking at what's the safety risk during the course of the project. And then if we know that, we can either design it out beforehand, redesign our schedule, or maybe we provide some training or some safety precautions at different points of that project. So that's integrating BIM, risk, and schedule. And those tools are becoming available for us. And that's it for my presentation. I hope you learned something about PtD, and I'm happy that you're here and interested in it. I would be happy to answer questions or provide additional information.
John, that was so fantastic. Thank you so much. We have a question here from Dwayne Caldwell, and he asks, I've found that most architects and many engineers know the building mechanical and fire codes, but are not familiar with OSHA requirements. I've had architects design to IBC, but many OSHA requirements are more prescriptive and restrictive. The architects state IBC trumps OSHA. How's that for a bunch of acronyms, right? Which we know is not true. This leaves the owner responsible to retrofit a brand new building or project space immediately after construction to comply with OSHA for occupancy and use. Here's the question. How do we educate architects and engineers to consider OSHA equally with ICC?
Yeah, that's a gap that you've identified, Dwayne, and also something that I've looked at in the past, where you have on one side, you have the IBC, which if you read through it, much of that focuses on the safety of the person who's going to exist in the building afterwards, right? Then on the other side, you have OSHA. If you read through the OSHA regulations, they're not very exciting, but if you read through them, that focuses on the process of construction. And it doesn't have a lot in it about the permanent structure. So there's a gap there in terms of resources and available information. So I can certainly design to the IBC as an architect or engineer. The OSHA regulations have a few requirements in there related to, for example, the base plate on a steel column must have at least 4 bolts. That's one of the only ones that I know of. There are some that relate to the design of the temporary structures, the design of the ramps, the design of the ladders, the design of the handrails, the temporary structures and equipment, but not really to anything related to the permanent structure. And so education is a big issue. I'm participating in a seminar series, a symposia series on safety, where we are going out to 5 different universities across the country to try to tell the people in the engineering programs, hey, safety is a big issue and we need to expand it within our engineering curricula. And so education is on our list of things to do to make sure that those architects and engineers know that in addition to meeting the IBC, that it's their design influences the safety of people during construction and maintenance. And there are these other codes that they should look at also, like the OSHA regulations. It's a very good question.
Thanks. We have a question from Jerome Schulte, which is there a resource to learn more about the UK obligations and requirements for designers related to PtD?
Yeah, quite a few resources. So one of the official title of the regulation is the Construction Design and Management Regulations, CDM for short, Construction Design and Management Regulations. And if you type that into Google, you'll find quite a bit. And if you want some specific websites, I can provide those to you as well. The regulations in the UK come from a European Union directive that was enacted in 1994 or 1995. So all the EU countries had to implement something. And obviously the UK is not part of the EU, but they have their own requirements. They're the most strict. The other countries within the EU have some, but not as strict as the CDM regulations. There are other countries around the world, Singapore, South Africa, Australia, other places that do have similar regulations. The United States, we don't have our regulations for designers to design for the risk of anybody downstream of their design, including constructors. So that's not part of what we do here.
That's very interesting. We had a conversation recently with someone from AXA Insurance, just about risk and how to mitigate risk to lower your premiums or the amount that you essentially pay for risk management on a project. And so they're very interested in supporting innovation and innovative ideas that will help their clients essentially lower their rates. So perhaps that becomes the driving force at some point for everyone is thinking about this from an insurance perspective, which seems to me a missed opportunity to think about it only from that financial perspective, but sometimes that does drive industry to make improvements or shift its behavior.
For sure, and perhaps it makes it easier for A&E firms to take on PtD if they know they're covered by their insurance. So focusing on errors and emissions insurance, there's documentation that I've created that's available. If you are looking to approach your E&O provider, here are some things that you can do to address, to help that process out and help on the insurance side. That information is available, as well as information about how to address it in contracts, in the design contract between the client and the designer or the sub-consultants. How do you address PtD in that design contract? There's information available for that too.
When we first started talking, I was reminded of the chief engineer for the Golden Gate Bridge, which everyone thinks is, a marvel and certainly very iconic for those of us here in the Bay Area. And the chief engineer made it his goal to reduce the number of deaths you might expect from bridge construction in the 1930s or, whenever the bridge was built. And I remember reading that as a teenager and being horrified that there was actually an expectation or an acceptable loss of lives in the building of something. And so they said, well, for a bridge like this, you'd expect this many people to die. And Strauss, who was the engineer, said, we're going to have no deaths. We're going to be the bridge. And so at this moment, that's what the Golden Gate Bridge is known for, its iconic structure, but really it's that hidden truth of the lives which were spared in the creation of it by some, new technologies and new ideas that he implemented at the time. And wouldn't that be a wonderful way for us to approach all of our work, is have that be the unseen, but the beauty of the end product, is that no lives were lost or people were harmed in any way. So, can we move towards an industry without harm? I think towards the people that do the hard work to make these structures that we all love happen.
For sure. Yeah.
That's great. John, I can't thank you enough for your time, your energy, and your presentation. It was so fantastic. We're going to unfortunately have to close now. We're at the sort of top of the hour. So I really want to thank you. Please keep us in mind as your research continues, because we think this is really important for transforming the profession into a place of safety and no harm for the people who build, design, and then ultimately use the structures of our lives.
Yeah, my pleasure. I'd be happy to share anything that I have. So
Great.
thank you.
Thank you so much. Our next scheduled webinar is next Friday with Sandeep Ahuja. Creating a carbon-free future lies in rethinking building design. Join Sandeep as she shares her innovation story that led her to found and lead the development of a software solution called the Cove Tool. It weaves energy, daylighting, and cost analyses into a user-friendly tool that is disrupting the design world. We look forward to having you join us. This concludes our online salon. To join us for future webinars, be sure to subscribe in our newsletter. Centerforinnovation.org is our website. Special thanks to Katie Olson for a new website, and also today for keeping us on track. And of course, all of our sponsors who make this possible. Thanks for joining us. And as always, if you have thoughts, comments, or ideas, reach out to us via the Contact Us link on the Centerforinnovation.org website. Thank you, and see you soon.